First conference talk, so nervous. um, all right. Well, today I'm going to be talking about SpawnFest 2023 and essentially how me and my team built what we built. So I'll get right into it. So I'll first cover a little bit about who I am and like kind of what I do on the day-to-day is sort of relevant to the talk. So I'm a software engineer at Corvus Insurance. We recently got acquired by Travelers, so Travelers Insurance. And at Corvus, we use Elixir, Elm, and that's our stack. I also run a YouTube channel with a coworker where we talk about all things functional programming languages. So we also talk about Elixir and Elm there. And that's sort of like a little background about me. So what is SpawnFest? For those of you that don't know, there's this really cool hackathon that happens every year where it's everything about the beam. So you can use Erlang, Clojure, Elixir, Alchemy, Gleam to build something in the span of 48 hours, I should say. So SpawnFest, hackathon, beam related languages, and you have 48 hours to do it. And this year there were, or I should say last year, there were 31 teams and 42 players in total that participated in SpawnFest. So I did not build the project that I'm about to talk about alone. I had two coworkers help me as well. So it was Chris, Andre, and Justin. And we all kind of came together to work on this project for 48 hours and build this out. So I'm going to be covering a couple of things today. Essentially, how I went about going to build this project, like where the idea came from. And then once we kind of had that initial idea, how we went about planning and designing everything. And then take you through some of the highlights of the development journey and building the project. So like using external libraries, working with gen servers, a little bit of prompt engineering, and definitely talking about different dependency issues. And if we have time, get to a demo and a wrap up with what I learned. So this whole thing kind of starts with Wix. Before SpawnFest, I was working with a nonprofit and they had their entire website and Wix, and I said I could help, modify some things, make it look better. That was a lot of fun. Not really. So it was just like, I can't really code with Wix the way that I'm used to, and configuration is just a nightmare. It would be great if I could just like type in a description of what I want it to happen and it would just work. So that's sort of where this idea comes from. We called it Elm Spark, kind of playing on an old cartoon that I liked, Kid Next Door, where everything has an acronym. And Elm Spark stands for Elm Software Produced by AI Responsive Knowledge. So the whole idea was, how do we build a front-end web application just using like a text description, like ChatGPT in the background? So after we had that initial idea, me and Justin started talking about what are things that we would need to have at a very high level in order to get this idea off the ground. So back and forth in the Slack message, we're like, okay, we need the ability to save Elm files on the server. We probably need the ability to compile files with Elm. We need to be able to take an input that describes the project, pass that to the large language model or ChatGPT or Claude, whatever, and get that to spit out some code. Probably we need authorization, maybe a page viewer to see what we've got, an editor, probably a wrapper for the large language model, and some other stuff. It was just kind of a high level plan. So taking that high level plan, there are a couple of big steps here in that plan. So we have this notion of the user needs to submit the blueprint for the web application that they want to actually make. ChatGPT or some large language model needs to write Elm code that fits that specification. The Elm compiler or the compiler in general is just going to give us back some nice error messages. And then we're going to go into this loop until we actually get a fully compiled Elm app at the end of this. So that was just the large high level plan. So how do we go about building this? And remember, we had 48 hours, so we did this pretty fast. So step one was thinking about, well, what the heck is a blueprint? But before we could even get to step one, we all decided to work on our personal computers instead of using our work computers. So we ran into other issues first. So the first issue that we had was Git issues. We had Eric Dubois as one of our contributors, like set into the Git repository at first. So we're all freaking out, like, oh no, we're going to get eliminated from SpawnFest because we have this random guy that's like on our team now. And it just came from one of the configurations for like, I think Andre's terminal was set incorrectly, and it was just like a default name that was pulled in. So after we stopped worrying about that, we were like, okay, we got to get stuff figured out. We we're like, what's next? It's kind of hard to code without a language server. And for whatever reason, we were running into language server problems, like both in like VS Code and also I use Emacs. So we're running into all types of stuff. And then after that, we were like, okay, cool. We got the language server fix. The Git issue doesn't really matter, I guess. And then we were like, oh, I guess we need an Elixir version to work from. So we have to figure out the ASDF stuff, which is nice. The things you take for granted when you haven't started a new Elixir project in a while and you're just trying to get things up and running. So that was sort of like our first like hindrance before we could even start thinking about what the heck we're building. But back to what we're building. So what exactly is a blueprint? A blueprint is essentially just a plan for the web application that you would like this system to build. And that's what we were calling the blueprint. So we came down and was like, okay, we need a title for the app that we're building. We need some type of description that describes what the app should do. But also there should be a notion of like an acceptance criteria or like QA steps. Like, how does the large language model know what it needs to build if we don't tell it what it needs to build? You know, code is only half as important as what you need to code, I guess. So kind of after we figured out like blueprint is basic title description and like QA steps or acceptance criteria, we're moving on to the next part. So how does ChatGPT or a large language model write the actual code? And we came up with this concept of a shell. And I'll go into that, what that means. So for people who are not familiar with Elm, in order to get an Elm application or web app running, you need to get it to compile. And essentially, if the Elm code compiles, then everything works about it, and it's really nice. And there are three kind of components to an Elm application. A simple one, that is, you have the view that represents like what you actually see on the website. You have the init, which represents like the starting state of your Elm application. And then you have the update function, which takes your state of the application and it takes some message and then it updates the state of the application based on the message that it takes in. So these are like the three necessary parts for an Elm application. And when you're starting to write an Elm application, you define this main function that takes in a view, update, and a init function that does the things I just mentioned. And then once you have all that defined, it should compile, you know, if everything works, hopefully. So we were thinking like, okay, we just need a shell of a program to allow ChatGPT or a large language model to write to. But before we can get that shell running, we need to just focus on one step at a time. So we don't ask ChatGPT to just write the entire program because it's going to hallucinate. It's not very targeted towards what it needs to do at each step. So we tried to break up this, like, write a whole Elm program into just write one piece. And we use tools from like the Elm language, like debug.todo, that allows you to just kind of have pieces of your code not filled in and just focus on like very specific things. So we got this notion of, okay, if we can use debug to do the kind of this fake like having code there, then we can just focus on one section at a time. And using this model, this shell model, we're like, okay, the first thing that we need to focus on is which should be the state of your application. Like, what does your model look like? What does the state actually look like? And we need to ask ChatGPT to define what the state or what the model looks looked at that time. And after we have that, then we can go build the other pieces on top. So that's essentially kind of the plan that we did here. We have the first step, which is asking ChatGPT to write some code that generates the model. And we add that model code onto the rest of the shell that's going to compile. And the only thing that is left to the large language model to figure out is the model itself. So we have this bottom piece that is ChatGPT generating the model, and then the rest of it should compile as is. So we know if the model piece is correct, the whole thing will compile, and then we can move on to the next step. So we have the model, and the model has compiled, hopefully, if all went well from the previous step. And then we're like, okay, once we have the model, we can add on another piece of functionality that ChatGPT needs to generate. So we're only focusing on generating the init function, which fills that model that it determined that it needed from the last step. And we kind of just go through this for each piece of an Elm program. So we define what the model should be with its types. We define the init that actually generates that model. Then we ask it to generate the messages, and we are appending each code from the previous step to this shell. So we get the entire thing, the entire program as it comes out one at a time. That's our entire process for like generating an Elm program, or theoretically at this point, that was our process. So we're like, go through all the steps. We append the model, the init, the message, the update, and this is all done with that like shell that gets smaller and smaller as we append more and more code that compiles successfully until we get to like the last step of generating the view. What should all this actually look like? So that's the high level plan. And we had that plan before we started any development, but we need to figure out just logically, conceptually, where we're going to go with this project. And this is probably 2 hours into the start of SpawnFest, and we have 45 hours left. So that was where we were at this point. So the way that I like to go about building software, it comes from like a Basecamp shape-up methodology, where you kind of decide that you have a giant curve that you're using to build something in a particular period of time. Our period of time is 48 hours. But in the first part of that curve, you're always trying to figure out what exactly you're building, especially if you're working with something that you have no prior knowledge on or experience, and you're just kind of going with a lot of guesses. So the first part of the curve is figuring out exactly what you need to do. So we're still figuring out what we need to do. We're kind of at the bottom of this curve. Like, we have that plan, we know sort of how it should work conceptually, but we haven't actually done any code yet. So as we start building the code out for this, we're still figuring out what to do. And then once we get to like the peak where we have the basic implementation working, then we're fixing up things and we're getting that project actually delivered. So that's kind of how we built the SpawnFest project. We started with 48 hours, we're kind of splitting it into two. The first 24 hours, we're figuring out how everything's going to work together. And then the second part of it, we are cleaning things up, making things nice and making things work. So I like to call this part running up the hill, because we're still figuring out how things are going to go. So we have our game plan. Now we just need to build it. There are two essential like things to our strategy. Well, one, obviously, we need some way of interacting with the large language model and getting all that code up and running. And then two, we need a way of talking to the Elm compiler. So the first step is super easy to do with an external library. We can just bring in X OpenAI, and then that creates a library for us to make OpenAI calls super easily. So first step was kind of check. The next step is how do we talk to the Elm compiler from Elixir? And that was less straightforward. So I was thinking, we could use system command, and that's how we can pipe processes and get information back from processes, right? So this step I called 0.19 because Elm is still on version 0.19. It's just kind of a funny joke, but we're focusing on getting the Elm interaction going. So the first couple of things that we need to think about is, what does Elm need to compile? And what Elm needs to compile is, it needs the Elm project initialized, which is just creating a folder and having some Elm dev files like in that folder. And usually you do that with the command elm init. So you run elm init, and then it asks you if you want to create an Elm JSON file and some other stuff. And then you just say yes, and you go and do that. So I was trying to mimic that same behavior, but from Elixir. So I thought it would just be system command elm init. And that did not work. And this took a couple more hours to try to figure out, like, oh, how can I initialize an Elm project using Elixir? And the issue essentially came down to learning how to use a pipe, things you take for granted. So the issue that the Elm init wasn't working with system command at first is because you need to actually type in yes to Elm init. And without that typing in yes, the system command was just kind of waiting until it timed out. And it took a couple hours to figure out, oh, okay, we just need to do like a pipe for the command that we run to automatically say yes for us in advance. So we got the Elm project initialized. So what else is what else do you need to compile Elm? So once you have a project initialized, you actually need a file to write to, where the code is going. So you need a main Elm file. And to get that, it was just pretty easy to do a file write, file.write, the name of the file, and the contents, would pass whatever variable you need for the contents of that file. And then lastly, once we have an Elm project initialized, we actually have a source file, like the main.elm file. We need to run the compiler to see if this file compiles. So we need to run elm make. And well, it should be easy as elm make source/main.elm once you have the Elm project initialized and the file is made. So we were just thinking, yeah, we should just be able to use system command elm make source/main.elm, and everything should just work. That was not the case. So I started getting really frustrated, and we're talking maybe 5-6 hours into the 48-hour hackathon, and we have no progress on compiling an Elm file, which is crucial to this entire thing working, really. So I had to bring in Rambo. Now, for those of you that don't know, Rambo is a library that allows you to run external processes, change commands, and it just kind of handles everything with the command weirdness for you, so you don't have to think about it. So after switching from using system.command to Rambo, things got a lot easier for that Elm step. So now I'm going to switch over to my code editor and hope everyone can see it. I'm assuming people can see it. So we have a gen server that is kind of in charge of doing those doing the steps that we just mentioned. So the Elm make server creates a new Elm project. It also runs the Elm compiler, and it handles all the command weirdness that we were talking about. We realized that we needed to use a gen server to encapsulate sort of the state of these different Elm projects that we're going to be creating for this. So we are using one gen server that manages where the project is initialized and how they create it, And it was fun kind of just going through and using a Gen server for this type of thing, because it's not really something I get to do that often for work. So we create a working directory when we create the new project from the Gen server, and we initialize the Elm project if there isn't one already in the local directory that we choose. And this is just the server that uses all of Rambo and everything to compile and run things. So when you want to use Rambo, you just call Rambo run, and you call the name of the process, you pass it the arguments, and you can even tell it where you would like to run that command. So it really is a lot easier to work with than system command, because it takes care of a lot of like the oddities of running the commands, and things just kind of work the way you think they should work. So once we had the Elm server up and running, we realized that, okay, we need to focus on the other part of the project, which is the large language model. So we pulled in OpenAI, and it was super easy to just use the ChatGPT library that way. But Justin was just like, we don't want to use OpenAI directly, because what if we decide to switch out ChatGPT for Claude or some internal like large language model? So we built a very lightweight wrapper around the large language model, so that if we decided to later, we could switch it out for a different implementation under the hood. So now that we have the large language model interaction working and we have the Elm interaction working, we need to actually get to the actual problem at hand here. It's like, how do we go from a blueprint, some textual description of a web app that you want, to an actual web app that you want? So we realized that, okay, we're going to have a pipeline similar to the pipeline I showed you about the shell and how we're generating at each step a different piece of the code. But that pipeline needs to start with a blueprint. So the blueprint has the title, the description, and how the app is supposed to work. And then we need to pass that blueprint to the large language model and get a response that we can then go on to generate the rest of the app. So the very first step that we did is we were working on how do we get from a blueprint, how do we get the model? Like what types should the model have? Like what data should the model have to generate this blueprint? And the first prompt that we came up with was, okay, given the title, the description, and the user acceptance criteria, what are the fields necessary to create a working application that matches the input, essentially? And we wanted it to list out the fields that it would need and their associated types to create that model. So that was our first message to the large language model. And well, things didn't work exactly how we thought they should. So the first problem we ran into is in its model, ChatGPT wanted to use imports that we weren't currently importing to the file. So when we wrote the show, we didn't have any notion of imports. We were just like, okay, give us the model. And we were just assuming that it would use things from the standard library that didn't rely on having imports. But it was not that smart. It was like, hey, yeah, you need that string function thing from this library. And we're like, well, we didn't import that. So the thing was always failing compilation. And then it wasn't being very good at imports in general. So we have to create a whole separate step just for it to process like what imports it thinks it would need to actually solve this problem. And that wasn't a thing that we saw beforehand as a need. So we went to the Elm website and we had to actually scrape all of Elm's documentation to get all of the libraries that could be possibly imported. And then we added a step before we asked ChatGPT what model it should create and be like, what imports do you think you need for this blueprint? and then it would give us back a list of imports. But we ran into another problem with the list of imports that it would give us back. Originally, we thought it would be enough for us to ask for a list of imports separated by a bar. But then we realized that if we ask for a list of imports separated by a bar, we're actually feeding into its training set data. So it has a bunch of training data on Elm code that is separated by bars. So if we ask for like, if it gave us back string bar char, it wasn't actually answering the question. It was just trying to match what should be the most likely next character when you're separated by bars, because there's a lot of Haskell code and Elm code that looks like bar separated list. So in order to deal with that, we actually had to ask it to separate by double @, because that was something that was not previously in the training set data that it could not necessarily like fill in from. So it started giving us like a good list of separations when we asked for double ampersand separation, which is sort of like a prompt engineering thing that you don't really have, you don't think about. You're like, yeah, I can use a comma separated list. No, you can't use a comma separated list because everyone uses a comma separated list. And then that's all in the training set. So suddenly you have apple and fruits like in your list for imports, but that has nothing to do with what you're asking it. So it just hallucinates based off of what it thinks is the most common thing that you can get. So that was a learning curve for us, but we got to a good solution. So this was the end prompt that we asked for. So from the blueprint, given the title, the description, the user acceptance criteria, pick modules from the available modules that you will need to build this project in Elm. Return the available modules that are separated by double @. Your response should look something like module 1 module 2 module 3 So this really lowered the overall hallucinations for this one particular task, and it all relied on the prompt that we worked with. And it just took time to figure out, like, this is the necessary prompt that you need to get the model to respond correctly. So going back to the code, so our first step in the entire process is generating the imports, which I was just kind of talking about. We get the available modules from the Elm documentation, which we ended up wrapping in a Gen server, so we wouldn't have to continually do HTTP calls to get the documentation from Elm's website. Then we create a new Elm program, which I'll cover in a second. And this Elm program is sort of like the abstraction of that shell that I showed before. So it's like you have different steps that can be filled in. But then this Elm program goes through a pipeline. And at each step in the pipeline, we are sending ChatGPT a message that is based on which stage of development we are currently in. And we are expecting ChatGPT to give us back an answer. Hopefully it's a nice answer that compiles and lets us move on to the next step. If not, we do some other stuff. But at this point, we have a Elm program that you go through each step, and hopefully if it ran into no errors, it will keep going through the entire process. And at the very end, get a Elm program that compiles. Just moving people. So essentially we have the user submits a blueprint, ChatGPT takes that blueprint, figures out what imports it needs, figures out what view, what model it needs, what messages it needs, what update function it needs, and it will give us the entire Elm app once it finishes the generate view step. So we're at like the height of our hill at this point, and it's been 24 hours and there's been no sleep because we just worked through the night, and we have it sort of working, and we're like, well, what's next? And this is sort of like the downhill. Like we have everything kind of compiling and going through the first step, and we're just like, well, it would be nice if we could teach it to learn from feedback, and if we could add some like styling things in that nature, maybe add some documentation, deploy it so other people can see it, the judges and everything. And we ran into some problems on the way down. So I was like, I'm going to deploy everything and it's going to work perfectly the first time, right? Right. And that was not the case. When we tried to deploy to Fly.io, we ran into some major issues with Elm. And it actually turned out to be a Haskell thing. So we had to go and look at the Haskell compiler code and try to figure out why Elm wasn't allowing us to like write stuff on Fly.io servers. And it actually turned out to be like an undocumented thing that you had to set. And I opened a whole issue about it. And it's just like, you think things are going to work out the first time, but then they don't. So now I'm going to show a demo of the application. Just trying to. Okay. So this is what we end up building. So you start everything off by entering like the name, the title of your project. And I'll just start with calculator. Then you give a brief description of what the thing should do. So it should be a simple calculator that adds and subtracts things. And then you want to give like the acceptance criteria, like how does it actually work or operate? And oops, it should have buttons that allow you to enter digits and click the equal sign to calculate the response. Then you submit that and refresh. And I already have a couple of these pre-made, so I'll just click one of these. So then it goes through and does the different steps. So the first step, it chooses imports. So ChatGPT at this step is figuring out which imports it needs, and this is what it comes back with. Then at the second step, it is trying to choose a model alias. And this is the model alias that it comes back with. And we're just continually adding on each step until we get to, well, it didn't happen here, until we get to the view and update when it's fully complete. So this program isn't guaranteed to actually spit out a running application each time, because ChatGPT can fail between each one of these steps. So I'm just going to retry it until we get this working well.
I just want to jump in really quickly. We're 5 minutes past time, so if you could just wrap up quick, and yeah, we'll give people a break.
Yep. So it actually went through all the steps here, and we can go back and see what it actually generated here. So it's very rudimentary, but in the sake of time, I'll stop here.